Algebra 1, 5.2.1a, add and subtract polynomials. So for our warm-up, we're going to just do some combining like terms. So first, if you look at the first polynomial, we have x squared minus 3x plus 5 and minus 2x squared plus 7x minus 2. So to add like terms, we will add together the terms that have the same variables, same exponents on the variables. So in number 1, the x squared can be combined with the negative 2x squared. And so you would add the coefficients, those are the numbers in front, 1 and negative 2, and you will get negative 1. So I'm going to use the equation editor for this. So you will insert an equation, and it'll pop up a toolbar for you. And then you can start using that. You won't have to go back to insert. So this will be negative x, and then I do shift 6 to make it squared. All right, then I have negative 3x and positive 7x. If you add a negative 3 to a positive 7, you get a 4. So 4x. And then finally, the 5 and the negative 2. 5 minus 2 is 3, so I get plus 3. So this is my new polynomial. So most of this lesson today, hopefully, is a review for you. I don't think there's anything new here, but I do want to go back over adding and subtracting polynomials first, and then we'll do multiplying polynomials tomorrow, and then we'll get into factoring polynomials, which is a little bit more involved. Okay, for number 2, we have x squared terms again, and here we have xy, and we have x. So the negative x squared and the positive 5x squared can be combined. Negative x squared is the same as negative 1x squared. So if you add negative 1 to positive 5, you get 4x squared. So I'm going to put that one first. Click on New Equation to get 4x squared. All right, and then I have an xy. Well, that's 1xy. And minus 4xy, if you add a positive 1 to a negative 4, you'll get a negative 3. So put a minus xy. And then finally, we have a 3x. That can be combined with your x. So 3x plus x is 4x. All right, so I'm going to highlight this one in red just so it'll stand out a little better. And then finally, on this part, we have an x, a minus y, and a 2x. Well, the x and the 2x can be combined to get a 3x. So I'm going to click on New Equation and put 3x. The negative y can be combined with the 4y. So that's like negative 1y and 4y, which is 3y. And then we have, let's see, a negative 3 and a positive 1. Those are alike. So we could add negative 3 and positive 1 and get negative 2. Now, if you need to do the arithmetic in a calculator, don't forget, you can click on the Desmos calculator to do your arithmetic. So use it if you need it. Okay, well, we've just been doing some addition of polynomials here, combining like terms in polynomials. So let's talk about some definitions because we'll need those to do the next problems. It says a polynomial here is a mathematical expression that includes one term or the sum of 2 or more terms. A term of a polynomial can contain a constant, which is just a number. It could have one or more variables, and those variables can be raised to integer powers. And it's important to note they must be non-negative integer powers. Terms in a polynomial are separated by pluses and minuses. So that's how you can kind of see where the terms are. The constants or the numbers that are multiplied by the variables are called coefficients. Now, polynomials are named according to the number of terms that they have. A polynomial with exactly one term we call a monomial, and a polynomial with 2 terms we call a binomial. Polynomials with exactly 3 terms we call a trinomial. If it's got more than 3 terms, we just call it a polynomial. The degree of a polynomial is the exponent on the variable. So if there's a lot of terms, then you would find the degree on the highest exponent would be the degree of the polynomial. So let's take a look at these problems. The first one says determine which expressions are polynomials. So if you go back to your definition, for a polynomial, you have to have numbers and variables. But the key here is that you cannot have exponents that are negative because we have to have non-negative integer powers. So this first one is not a polynomial. So I'm going to go ahead and write not a polynomial. And it is not a polynomial because it has a negative exponent in it. All right, so let's go ahead and put that. Now the second one has 6m squared, so that's a number 6 multiplied by a variable m, an exponent of 2. Well, that's not negative, so it's okay. The next has a plus 4m. 4 is a number, that's called a coefficient, and m is a variable. I don't see any negative exponents. I think we're good, and then plus 2. So this is a polynomial. It happens to be a degree 2 polynomial, but we'll talk about that in the next set of exercises. Now C has k to the 5th, and that is that's fine. You have a variable k with an exponent of 5. 5 is not negative, minus the square root of n. Well, here's the problem. We cannot have a square root in a polynomial because unless it's the square root of a number, which would be okay because the square root of a number is just a number. But if it's a square root of a variable, that's telling you your exponent is really a fraction. So you're not allowed to have a square root of a variable in a polynomial. So not a polynomial. The variable cannot be under a square root. If it's a polynomial, you won't have any square roots on your variables. Okay, the next one, whoops, I meant to make that red and it didn't happen, so let's try again. There we go. For part D, I'm not sure what happened to my letter here, but we should have a D there. Let's make that D. This one is not a polynomial, and I'll tell you why. It does have a 6m squared, and that part's fine, but it has a 1 divided by m. 1 divided by m is the same as m raised to the negative 1 power. Well, the directions tell us, or in the definition of a polynomial, you cannot have a negative exponent. So 1 over m is a negative exponent. It's m to the negative 1 power. So variables cannot be in the denominator for that reason. So it's not a polynomial. M is in the denominator. Which means the exponent on m is negative 1. And we can't have negative exponents. All right, so anytime you see a variable in the denominator of a fraction like this one, that's your cue that it's not a polynomial. All right, let's go to the next one. Number 2 says identify the terms and the coefficients in each polynomial. So remember, the terms are separated with pluses and minuses. In 2a, there is just one term. So we're going to say the term is the whole thing. And I'm just going to copy it. It'll make this faster. So let's just copy that and paste it, or just retype it. Next, the coefficient. Well, the coefficient is just the 2. So it is the number in front of that term. It's the first thing that's written. Then next, classify by the number of terms. This is a monomial because it only has one term. There's no pluses and minuses separating anything, so it's just one term. Okay, the next one, identify the terms. So the terms are, and I'm going to separate these with, let me write this in red so it sticks out. I'm going to separate these with commas. So the first one was 5m to the 3rd, and I'm just going to paste it. So we'll put that here. You can type it if you're not able to paste. I don't know if you can paste on a phone. Y'all let me know if you figure out a way to do that. Uh-oh, what am I doing here? Oh, I'm in a, all right, let's put a comma, and then I'm going to paste this one. And then I'll put a comma, and then I'll paste the 3. So these are my terms. You have 3 terms this time. All right, the coefficients, those are your numbers. Well, let's see. 5 is the first one. The middle one is not a 4. It's actually a -4. You have to use that negative sign that goes in front of it, or the minus sign is the sign of that term. So be sure to put a -4. And then the 3 is a constant, but it is also a coefficient. All right, and then finally classify by the number of terms. Well, in this case, I have 1, 2, 3 terms, so this is a trinomial. Okay, the last one, identify the terms. Well, these are the terms, so I'm just going to copy the whole thing and put terms, write it again, and put a comma between them. So the first term is the the k to the 5th, and the second term is the negative m, or negative n. Next, what are the coefficients? Well, k to the 5th has a 1 in front. You can't see it, so you know it's just 1 k to the 5th. The minus n has a -1 in front. So the coefficient for the negative n or the minus n is -1. Okay, next. Classify by the number of terms. Well, this one is a binomial because it has 2 terms. It's separated by the minus sign in the middle. Okay, the next part, 3, says determine the degree of each term and then the degree of the polynomial. So I'm going to copy this over. I'm not going to mess this up. Just copy the whole thing over. I'm going to color it red so I can keep it straight. All right, so my 3x squared is degree 2. And then I'll put a comma because the x squared has an exponent of 2. The minus 2x is degree 1. Because the exponent, you can't even see the exponent on the x, but it is a degree 1 because there's only one x in this term. It's not x squared, x cubed, or x to the 4th. And then the 5, or the plus 5, you don't really need the plus. I'll take that out. The 5 is degree 0. That's because there is no variable x. That's like an x to the 0 is a 1. So you would say degree 0 if you don't see any x's in a term. All right, finally, the degree of the polynomial is the highest of the 3. So which one was highest? Whoops. Let's see. The highest one was a 2. So the degree is 2. Back up a little bit to get all that on one row. Okay. So that's what we're doing. So the next one, I'm just going to copy this polynomial. I think I'll put it below so I don't have to worry about space. Back up so I don't have that. Wait a minute. It's so hard to get these little counter things off. They just want to cut. There we go. All right, so I'm going to make, I don't want that one. What did I just do? Control C. I'll put it here. All right, we're going to make this red. Or not. Let's try again. All right, so -9. There is no variable on it, so it's degree 0. 2x to the 3rd. I'm going to take off the plus because I don't really need that, but the 2x to the 3rd is degree 3 because the exponent on the variable is the 3. And the -2x to the 6th, that is degree 6. So the degree of the polynomial, let's put that down here. Degree of polynomial is degree 6 because the highest one was 6. All right, I'm going to leave some work for you.